So this is a quick reminder of what we were doing before break. Sine started at 0, 0. Cosine started at 1. And do you remember that these spots were really important? Right here. 1 pi over 2. I called that 2 pi over 2, and that's 3 pi over 2, and then 4 pi over 2. All right. So let's just take a minute to go off to the side and say, what if I asked you for 2 sine of 5 theta? So graph regular sine. It's the one that looks like this. And then make sure you hit all 4 important spots with labels. Label this and label this. And then after you're done graphing normal sine, factor in that 2 and that 5. And I'm going to pause for a minute to see if you remember how to graph plain old-fashioned shifted, stretched sine. So I'll call on various assorted people to help me graph this thing. Alex, can you tell me the x and the y-axis labels? Alex K. Pi over 2, good. And start with hint 1 pi over 2, and your life is so much easier if you say that. It's because then what's the next one?
2 pi over 2.
Keep going.
3 pi over 2. 4 pi over 2.
Exactly. And I know they reduce, but it's so much easier to count that way. When we shift it to the right, you'll thank me, because then what would the next spot be, Alex?
5 pi over 2.
Yeah, and if I had you do it the old-fashioned way, and you would have said this was 2 pi, then you'd be like, I don't know what's next. But when you do it this way, it's so obvious. Okay, good. Now the x and the y are 1 and -1. That's just too easy to ask somebody. All right, Cooper, how do I change with this 2 as a y stretch factor, a vertical stretch factor? Where does that go?
You just change the 1 and -1 to 2 and -2.
All right, and just so you could see visually what it would have looked like is kind of like that, but we don't make you do that. We instead just have you relabel this with, like you said, a 2 and a -2. All right, and then the last thing is, Vivian, what does that 5 do to everything? Okay, so you seemed like you would multiply by 5, but you don't. You multiply by 1/5. 1/5 on all of these. So then you pretty quickly get the idea. It's 1 pi over 10, 2 pi over 10, 3 pi over 10, and 4 pi over 10. Could those be reduced? Sure. Okay, so what could I graph on top of this and save myself a ton of time? If I needed to graph a different function, but not sine, but what's the other one that's like sine? Cosecant, yes. Everybody right above this, change colors now. I'm going to change to blue. I'm going to graph y equals 2 cosecant of 5 theta. And that would mean I would have started by graphing sine, just like I did. And then I'd put asymptotes here, and here, and here. Because why? Because cosecant is 1 over sine. And wherever sine was going to hit 0, which is here, and here, and here, then it won't be 0. It'll be 1 over 0, and that doesn't exist, so there's asymptotes there. And the last part of the cosecant graph is you make these little loops like that. Why? Because at this spot, it's 1. Y is 1, and when you put 1 over 1, it's still 1. So they share that spot, the top of the peak. And then as this one gets really close to 0, here and here, the height becomes really, really small. 1 over a really small thing is like 1 over 100th, which is really like 100. So the smaller this gets, the bigger this gets. That's why those loops do what they do. And that blue one is cosecant. Now we could do this all over again, except I felt like it was kind of a waste of time last hour to do the same exact thing except with cosine. But do you get if I had you graph cosine? It'd be a lot like graphing sine. And then what's the one that would ride on its back? Secant. So speed version. Watch Mr. Server graph cosine. Stops at 2 pi. Starts at 1 pi over 2, 2 pi over 2, 3 pi over 2, 1, -1. And then if I want asymptotes, they'd go here and here, because that's where secant has asymptotes, because it's 1 over cosine. And then I just need these little loops like this, and this, and this. And the red one would be the graph of secant. If I extended it out, you'd see more like these are regular loops. But now I've graphed more than one period of it. Okay. Everybody please write this. Y equals A cosine of B, parentheses, x minus, what do you think I'm going to put? C minus, oh, plus, sorry. All of them are pluses except the one in the middle. Plus what? D. And that's above it, right, what each one means. What's the A stand for? It even, like, has the right first letter for amplitude. That's the amplitude. Better unjacket yourself. You get two layers, you're going to fall asleep, too warm. Okay, and John, do you remember something important about B? Has to do with the what?
I don't remember.
All right, it's an equation, and I'll start it for you. The period is something over something. Does that ring a bell? 2 pi over B. And I'll use a capital B. Could use lowercase, but we seem to have capitals in our notes. So. Period is 2 pi over B. That's an important formula. All right, next up. That's got two words. First word P. Second word S. Anybody remember the name for that? C? Phase shift. Very good. The C is called the phase shift, and the D is just how far up or down the thing has been moved. Okay. If you wanted a fancy name for it, you could call it a vertical, because it's on the outside. High-vo, right? Horizontal inside. Vertical changes are on the outside. So that could be a vertical, and then you could just say translation if you wanted to be all fancy. All right. Now, why was that important? Because we learned before you took off for break how to take waves like this and write them as a cosine equation. And all you needed was a high spot and a low spot. Now, would you agree that temperatures are something that you can't totally depend on for like high temperatures for the day? You know what I mean? Like I looked the other day when I was in Florida and I was looking back at Minnesota's temperatures and I'm like, ha, it's so much nicer here. And then I looked like 10 days from now and Minnesota was actually going to be nicer than Florida was. Like Minnesota is going to be like 78 and Florida was going to be like whatever. My point is that Minnesota all of a sudden had really good weather compared to Florida, which is crazy. Like we're going to have high 70s, maybe 80 in a few days. All right, so temperatures you can't really count on, but the amount of daylight you have each day follows a very regular pattern. Do we ever get like a surprise day where like, whoa, we got way more daylight? No, we never have that. We follow a predictable pattern. But you know where it's way more predictable than Minnesota? At the equator. Very good. At the equator, the time for the high amount of sunlight in the day versus the low amount of sunlight in the day, it's super predictable. It's 6 a.m. rises and 6 p.m. it sets, and you got 12 hours of sunlight every single day. Okay, in Minnesota, is it like that? No, because some days, like in the winter, we get very little sunlight. In the summer, we get more than they do. This kind of makes up for it. All right, so I'm going to give you 2 times here. We're going to say that this happened at 4 for our x, like let's say 4 p.m. We had our highest amount of, I'm going to make this ice cream sales. It doesn't have to be sunlight, all right? So let's say that we sold $100 worth of ice cream right there. But by 6 o'clock, like right at dinner time, maybe people were not coming in to buy as much ice cream because it was dinner time and they were all like at restaurants instead of at the convenience store where we're selling ice cream. And let's say it went down to only $50 of sales at 6 p.m. And then maybe it keeps cycling like that because like late at night people get the munchies and all of a sudden they want to go get some ice cream, and so later on there's another high. All right, so I'm just making up, there's a lot of things that do cycle like this. Could be sunlight, could be temperatures, could be tides. So if I just had these numbers, do you remember me telling you that the dotted line down the middle was like super critical? And then we're going to use that cosine thing again. A cosine of B x minus c, and that x could be a theta and it wouldn't matter, plus d. And I'm going to remind you quick how this goes. So I would take notes and pay attention. And if you can do this, the only thing that gets more complicated, pay attention, is that and that. Sometimes you have to like think about the data and go, how can I make this into an x and a y? Like, how do I get this data from the real world charts? That's the hard part. I've got to make sure you're good at this. Once you have the x and the y point, I got to make sure you can do it. All right, so here's how you do it. That line down the middle is exactly between 50 and 100. So that's, what's exactly between those two? 75. So $75 is our midline or center line that goes right down the middle. This dotted line here, that's at 75. That's how far up the thing has been shifted, so that is 75. Now, from the 75 up to the 100 is height of 25. That little thing right there is 25. Do you know what that's called? Amplitude. So the amplitude is 25. We always use cosine. One student last hour said, why do we always use cosine? That's a good question. Because then we can say that this shift is always super easy. It's always how far over is the high spot. Because cosine's high spot normally would be here, and we're just saying how far did it move over. And so that's the x value. And so that would be right there. That is the x value of the first peak. All right. And now we just have to figure out B, and that's always the hardest part, but we talk about it a lot, so hopefully you'll get it. Yeah, A was 25. The phase shift was 4. So how far over it was shifted right here. That was how we got that. And this height is 75. That was a dotted line down the middle. $75 in sales. Okay, so then what's B? Well, you got to go to that formula. Mr. F, do you remember the formula for this? Period is, can you finish it?
Oh, period. 2 pi over b.
There we go. So then they did not tell me B. That's the point. I'm trying to figure out B. So they must have told me the period in some strange way. They did. Because between 4 and 6 is 2 hours, but that wasn't a complete cycle. It's really common for people to think right there is where I put 2 is the period. No, that's from the high to the low. Is this a complete cycle? No, it's only half a cycle. So 2 hours got you half a cycle. Do you get why I'm putting a 4 for the period? Because 2 hours got me from a high to a low. So get from a high back to a high again. This is a complete cycle from here to here. I need from a high to a high. So I got halfway was 2 hours, then the whole thing must be 4. And if you can't solve this, you don't know basic algebra, but I think you do. So I think you'd be okay with this part. And you get 2 pi over 4. Should you reduce? Yes, of course you should reduce. Jack, go get a drink. Keep on falling asleep. Go get a drink. Just take a walk. You need to wake up. All right, so I'm going to make this be into 2 pi over 4, which I'm going to reduce to pi over 2, which goes right here. And there. That is a equation. What does it do? If you give me an x, which you got to know what that is, that cows? Chickens? Burritos? What the heck is X? Time. If you give me a time, I can tell you the what. Well, in this case, it was the sales. It was $75 of ice cream sales. On other problems, of course, it won't be that. So if this follows a regular pattern like this, then I'd be able to say, here's my equation, and you give me a time, and I'll tell you how much ice cream we're going to be selling at that point. Okay. I need to give you another one, and you need to be able to do this with a partner, because this is hard, and it's not going to be something you'll be able to just like fire off in 10 seconds. I'm going to give you a high spot. I'm going to give you a low spot. From that data, you got to be able to just like write a cosine equation for this. Okay, so everybody copy this down, and in a second, I'm going to actually have you slide over in a second, and I'll pair you with the right person. We're going to make this about sunlight, and we're going to say that the highest amount of sunlight happened on day 175, and the amount of sunlight was 14 hours. Day 175. The highest amount of sunlight we had was 14 hours. In Minnesota, that's actually not that far off. The longest day might have been on the 175th day of the year. That's late June. You guys know what it's called? The day where you get the most sun? Summer solstice, very good. And then later in the year, you get the lowest amount of sunlight. If there's 365 days in the year, which we are going to allow you to assume, I'm aware it's actually more complicated than that. It's because of the leap years and all that stuff, but we're just going to say you should be able to use math to figure out what this is. I'm going to tell you that there's 12 hours of sunlight. Let's see, that's here. But you have to figure out if there's 365 days in the year, what would that be? Well, you don't add 365. Think about it. Don't talk about it. You'll talk with your partner in a minute. Once you have this number, we'll verify that fairly early to make sure you don't screw up the whole problem. Then you can write me this equation. A cosine of B parentheses theta, it could be an x, could be a theta, minus C plus D. All right, so first job, figure out when in December, like day what of the year, would your lowest amount of, and don't use like look up the summer solstice and the winter solstice. Use the fact that there's 365 days in a year to figure out what to put there. All right, so figure that out, and then we'll proceed to get the whole equation. The dotted line down the middle will be super critical. All right, I'm going to pause while you and your partner work on that. Okay, let's see if you got this. If we added 365, which would have been logical to get this amount, see how that would have gone too far if you added 365? Okay, so to get this amount right here, we don't add 365. We want to add half of 365 to get this number right there. All right, so 365 divided by 2 is 182.5. I know that's a bit of a pain, but that's exactly what that number should be. So I take the 182.5 and add the 175, and I would get 357.5. 357.5. Now, does it make sense that late in the year, like not day 365, but late in the year, like day 300 and something, is when you'd get the lowest amount of sunlight? Okay, and then this bond is right exactly between 12 and 14, so that'd be 13. So this assumes 13 hours is the midline. And then that tells us when you go from 13 up 1 to get to 14, that's our amplitude is 1. because it's from the dotted line up to the peak, which was 14. So that's 1. Cosine of b, that's the hardest part. Well, period equals 2 pi over b. And I don't know b, so I can figure it out by using the period. And the period will be 365. Why? Well, because from here to here is half of 365. And when you go from the high to the low, does it take a full year to get there? No, it takes half a year. So a lot of people feel like it's all finished when you hit here. I get that. You think it's finished, but it's not. It's only halfway finished. To get completely finished, you have to get to there. So that is the full period, and that is 365. All right, so then I'm going to times both sides by b, and I get b equals 2 pi over 365. 2 pi over 365. I get that's tricky, and I'll be willing to explain it again if you want. And then last is the phase shift, is how far over this was. How far over was that? 175. You can just take the x value of the first peak. And last but not least is the d, which is how far up this whole thing is shifted. You see how it's up there? It's up how far? 13. And yes, that is the midline. This last one is just the midline. If you want to make yourself some notes on this, that's the midline. I've also seen it called the center line. That is the x value of the first peak. This, if you're dealing with something that has a year, then you can use 365 as the period of it. So then you're always going to end up with a 2 pi and a 365, so it's 2 pi over 365. And last but not least is the a. How did I get the a being 1? That's because the midline from there up to the peak was 1. From 13 up to 14. All right. Now, I'm sure some of you made a mistake on that one. Be honest, how many of your groups had at least one mistake in your work? All right, good. So let's just do one more problem, and I'm going to give you a little bit of coaching through it because there's one like this. So pay attention. This is a not a roller coaster. What's the other thing called? You ride this ride and it just goes around and around and around in the circle. Thank you, Ferris wheel. Okay, so it's a Ferris wheel. And we're going to say that the Ferris wheel is 100 feet in the air. That's pretty big. And we're going to keep it really simple and say that the Ferris wheel just, the lowest it ever goes is at 0. They've kind of dug out a ground underneath it so that you can step on at ground height. Okay, so they may have had to excavate a little bit, but we're going to say that it's at 0, and the peak that you ever hit is 100 feet off the ground. So you go from 0 to 100. Now, as soon as you understand that, the first thing I would always draw if I were you is a wave that goes like this. They all do that. How far over to shift it? It's kind of a judgment call, but it'll have a highest spot somewhere. Okay, copy this down. You're not writing. You're not writing, so you need to copy this down. So now I got to tell you a few more things about this Ferris wheel, so that you can write this. You already know, if you're thinking about it, you already know the highest spot and the lowest spot. And technically this line goes right through there, because you know how the lowest spot hits the ground? So I'm going to just move my x-axis up. But I've said it a bunch of times. Let's see if you remember it. What is the most important thing to start with? What's this called? Midline, or the center line. And you have to have a point here and a point here, a high spot and a low spot. Have I told you everything I need to get you that? Not yet. You could get the high spot, because I know the highest off the ground that you will ever be. I already know that. I already told you that. And I know the lowest you'll ever be off the ground. The one thing I haven't told you is the times. So I'm going to tell you, you got on this roller coaster. Actually, no, I'm going to say it this way. You didn't check until you were at the highest part of the Ferris wheel, and you looked at your watch and you were like, oh, it happens to be exactly 2 o'clock. And how high were you? 100 feet off the ground. Then you wait till you get off of the thing and you go, okay, from the highest spot to the lowest spot, it took you 1 hour. Now, there aren't any that go that slow. I went on a giant one in Las Vegas. That was pretty cool. But there's one in London called the London Eye, which is this huge Ferris wheel. It goes super high. But I'm just trying to keep your numbers nice. We're going to say that we got off of it at 3. And what height were you at then?
0.
Do you get now? I have effectively told you what the period is, and it was not 1 hour. All right, so you and your partner, figure out what A, cosine of B times x minus C plus D. Figure out A, B, C, and D. I'll pause for a minute while you guys work together. Okay, see, that didn't take very long. And what's the hard part? It's going to be figuring out the x and the y of the highest spot and the x and the y of the lowest spot. Because once you got those, now this is how fast it can go. All right, so I'm starting with that midline. And that has to be exactly between 0 and 100, so it's 50. And that tells me this is 50 because this thing has been shifted up 50. And then from 50 to 100 is also 50. That always like that? No. It just happens to be this case, from 50 to 100 has an amplitude of 50. The cosine of B, well, that's period equals 2 pi over B. And the period was, well, it took 1 hour to go halfway, so the period was 2 hours. It's not that complicated, you just double that number because you'll only be halfway when you go from the high to the low. Okay, and then I have to solve this thing for B, and I get B equals 2 pi over 2, which is the same as pi. So B equals pi, so that's a pi. Or 2 pi over 2 is fine. And last but not least, it's shifted to the right. Well, how far is this? That's how far you shifted to the right, because cosine should be peaking right there, and it's instead peaking over there, and that's the x value of the first peak, which is a 2. There is your equation. If you told me a time, I could tell you how high off the ground you were. All right, now why are these hard to figure out? Like, what if this is January 21st, a date? Well, then you'd change it to a number. January 21st happens to be like 175. You can't just always be given these numbers. That's the only part that's hard. All right, so let's get some homework. Everybody take a look at... This one's actually so different than all the ones we just practiced that we'll maybe skip it. But this is a lot like what we just did, so you should definitely be ready for this one. And then I would skip the yo-yo one and do this one, because it's got a nice chart of real-world data. Guess what you're going to be looking for? The high spot and the low spot. Once you figure out the high spot's here, which it's not, I'm just saying it is, and the low spot's like here, and it's not, but I'm just saying, if I find those are my two spots, then I got a high spot and a low spot, and I can do everything I just did. My advice, though, always make one of these. It'll be so much easier if you label your high spot here and your low spot there. Make yourself a little picture like that for all of them. All right. Now, you got a partner. Why don't you work on one of these two and see if you can finish it, and after that, slide your desks apart then and continue on your own. Okay, so work on one of those two real-world problems, concrete together, and that's all I got for the video for today.